So thank you. I really appreciate all of you coming to my talk. And it's already towards the end of this conference. And I realize that maybe most of you have plans already for the weekend. So I have a lot of respect for you for still coming to my talk. So I hope it will be useful for you. So my topic is about deploying a modern serverless reactive container to the cloud. And as such too, I will be focused a bit more on talking about the specific library that I'm going to be talking about. But then I'll also give a bit of an introduction to reactive technology because I cannot assume everybody already know what that is. So as such, this talk is intended more for kind of people wanting to get to know reactive. And then I'll show a bit of the deployment to OpenShift running on the cloud. And specifically, I'm a developer advocate at IBM, so I'll be using the IBM cloud. And there's also OpenShift cluster that's running there that I will be showing. So, and if you'd like to follow me, this is my Twitter handle. So, okay, so with that, let me start. It's always a challenge. Okay, all right. So, so today, as I mentioned, I like to kind of bring up first about why Vertx. Vertx is an open source project, and it's an Eclipse Foundation open source project. And it's reactive in nature, and it's actually very lightweight. So supports like event-driven systems programming, and is really the asynchronous engine that powers Quarkus. If you're familiar with Quarkus, it is a cloud-native ready library developed by Red Hat, and it's a relatively new library, and it's highly efficient. I won't have time to actually talk much about it today. If you're interested too, we can kind of get more into that later, or maybe I'll point you to some resources too. So as such too, it is a library that's actually supports both imperative and reactive in the runtime. So it's very efficient, and not only that too, in the build phase of it, it trims down a lot of unnecessary things that are there. So it makes your executable deployment and everything a lot more kind of nimble into your cluster like that. So that's Quarkus. And so I'm kind of excited. Actually, for me too, I was trying to determine like which library to do when I learned about Quarkus and knowing Vertx behind. So that's why I wanted to spend more time to do some work about it. And also my weekly Twitch, which Swapnil so kindly mentioned about, that code in Twitch, I also will have some examples in using Vertx as well. Okay, so that's one thing about the Vertx, and then get more into it. It's a very flexible toolkit. It really supports like interoperability, very flexible. It doesn't force you the language that you want to write in because it's very polyglot in nature. You can actually write your Verticle, which is a unit of deployment in Vertx. You can write that in any other languages that supports it. For example, Scala too, and Python, JavaScript, Ruby, you name it, Kotlin. So yeah, so opportunities are unlimited. And to me too, I've been very interested in doing reactive and all of these work because of the asynchronous nature, and you can actually build out your pipeline, made up of different libraries, and they can all be communicating with one another, especially if they support, in the reactive Java world, if they support the reactive stream specification, that actually is truly interoperable. It's kind of fun to do, and that's a project that I'm going to hopefully start on when the holiday time comes. I have some time. I want to build like a hybrid, data pipeline that have different library implementations to it. So, okay, so with that, I should move forward. So about Quarkus, so some information then about Quarkus and Vertx. So as such, if you use Quarkus, you wouldn't know about Vertx if you just look at the surface, because Vertx is what goes on behind the scenes, like underneath. So when you look into your application, it goes into the routing layer. Then from there, it's actually handled by Vertx, and Vertx handles. It has a very efficient event bus that essentially the event loop and the vertical model of Vertx, they work together kind of hand in hand. And then it takes care of the requests and responses by the request handler, for example, like for HTTP. So, okay, so if you wanted more information, you go to the vertx.io, or actually the Quarkus at quarkus.io, you can find more information about Quarkus as well. But let me also then now turn a bit into talking about reactive Java quickly. Reactive as such is less of a hype these days. I mean, it was for a while, I think in kind of like the mid 2010s, the last decade. And now to me, I feel like, well, it's kind of still very important, but not many, kind of actual production systems have adopted it yet. And the reason is that it's kind of requires a bit in the change in how you think about programming. But as such, at this conference, I'm sure everybody wouldn't have any trouble because it's essentially the functional style of programming. And also too, specifically too in Java, it kind of time was ripe when reactive Java, all these libraries come out because since Java 8, there is stream processing, support for streams. And then for functional style of programming, for lambdas, all of these time, were ripe. And the reactive stream specification, which is a specification that kind of dictates, or not, I shouldn't say dictate, but guidelines to help to define how asynchronous processing can be handled properly for non-blocking scenarios and non-blocking asynchronous scenario, and also to handle back pressure. So that's kind of one kind of major thing for the reactive streams specification. And that reactive streams is actually based on Java 9, the Flow API too. So, and as such too, I want to kind of point out too, there's also difference too when we talk about reactive Java, because there's reactive programming, which is the functional style of programming. And of course, if you talk about functional programming and functional reactive programming, then there's also kind of differences in there too, because reactive programming, we're talking about, kind of really focusing on the data, the flow of it. And it's a bit more focused on the data. So what kind of moves your system, the flow, is really this changes in state of the data that moves it, down the pipeline on the flow. But for functional style of programming, we know it's more based on like a thread of execution. So based on the thread, your program will kind of execute. So that's why too, I think in a lot of folks too, when I spoke with them or, my audience in some of my previous presentation on an introductory reactive programming, there were people asking like, well, why you're doing, your functional style programming, because let's say we're doing a observer or an observable, and then we're, have all these events, and then we're doing a subscribe to what will come later. It's actually, we're subscribing to something in the future. So then folks were kind of asking, well, how does it actually work? So anyway, the point I'm trying to make is that it's kind of requires a little bit of different way of thinking because of the asynchronous style of processing involved. So, okay, so I'm sure that with our audience here is less of a concern to kind of understand functional programming. So I won't go into as much detail like I did with some of the conferences that I've been to. Now, then let me talk about reactive. So I talk about reactive programming, reactive streams. So now there's also Reactive Manifesto. So Reactive Manifesto is what kind of provide a guideline as to what reactive system should be. And it's a Lightband kind of a guideline that is led by Lightband. And essentially too, there are 4 tenets of Reactive Manifesto that guides like what a reactive system should have. So, so let me very quickly go over it. It's essentially too, fundamentally is the responsiveness, meaning that requests going into a system, they need to be handled, on a very timely basis. And that's essentially what it is. And then there's also, actually, let me go to elasticity. So elasticity means that if, your system is under load and a lot of requests coming in, then your overall system should then be able to handle all of the, additional requests that are coming in. So then, then you don't have the problem of back pressure building up in there. So let's say, your Valentine's Day is always a good kind of example, an e-commerce system for handling flowers. So right before Valentine's Day, there will be a lot of orders. So in those circumstances, then your system needs to be very scalable, really quickly spin up a lot more processes to handle all of these orders accordingly. And that's elasticity. So when it's like, not a busy time, then your system should then scale back down. So then you can release some of those resources to handle some other scenarios, some other maybe systems, within your whole ecosystem. Okay, so that's elasticity. Then we move over to the right side about resiliency. It means that if there are any kind of error condition that occurs, then likewise, it also needs to be very responsive, be able to handle this error right away. So then the overall system should not suffer too. The response time should not be suffering. And then there's also resiliency when you have maybe like one, some component in a cluster that's down, then it immediately should come back and kind of cover what's been down. You should have some way of kind of replacing that, or maybe fixing it right away and making it available again. So those three are kind of like the principles and tenets. And with the fourth one, that's message-driven. So message-driven, to me too, I kind of look at it as more like an enabler. In order to enable all of the three other, kind of tenets happening, it's really your system needs to be loosely coupled, very message-driven in nature. So they can, all of the components are, not tightly coupled. They all communicate with one another through messaging. Now, there's a bit of a difference too between like message-driven and event-driven. So message-driven is about messages that they have a known address, so they know where they're going to. The sender knows where it goes to a receiver. And likewise, if they can turn around, they communicate with one another. Now, for event-driven, that's more about in cases like a pub-sub type of scenario, producer and consumer. So any events that happen, they're emitting, the source emitting some data. It doesn't know where it's going to, because it is up to the consumer. Whoever is interested in it will need to subscribe to it. So like subscribe is kind of a terminology kind of borrowing from reactive extension. You have observables, streams of data, and then you have your your consumer subscribing to the data that will happen in the future, kind of like that. So that's more event-driven without like a fixed address. Its address would be unknown. So that's that. Now then, let me quickly also come and talk about some of the reactive frameworks that are more popular in the Java world. So just now I mentioned about Reactive Rx Java, Reactive Extension, Rx Java, and there are other languages implementation of Reactive Extension. Essentially, it came out of Microsoft, the Rx.net, and then Netflix saw the potential and really kind of took it, kind of turned it around and kind of ported it to Java, Rx Java. It's very popular with Android developer, especially with Rx Java 1. But Rx Java 1 doesn't have any support for back pressure. So Rx Java 2 is the flowable that actually has back pressure support. And basically you can have streams and then you can do it to flowable, and that can convert it, essentially your observable stream, into like flowable with back pressure too. Okay, so then now Vertx, and what we'll be talking about some more. And I also want to point out this library called SmallRye Mutiny. It's open source library, but the Red Hat folks, like mostly, they are kind of leading this effort too. So SmallRye Mutiny is, you may be wondering, well, another reactive library? No, because what they're trying to achieve is to streamline what used to be all of the Rx reactive extension operators. There are tons of them. And then because they're run into problems, too many operators, too many methods in an interface. So they basically do like a trimmed down version of, like a reactive library that's more kind of more efficient too, so to speak. And also too, it also have better pipelines it could help with different languages, and it supports like different languages too in the operator, that side of things. So among a lot of benefits to it. So, okay, so that's SmallRye, Mutiny. And then there's also MicroProfile, which is also an Eclipse Foundation project. And it's basically, you see that the small print here, Enterprise Java. So it came out more from the Java EE kind of side of things. And now it's actually, MicroProfile is a separate project that's lighter weight that would support, essentially focusing on support for microservices. It has support from reactive messaging, and it also has this set of reactive operators as well. So again, it's more a focus for building microservices. Then, of course, there's Akka. Without explanation, we all know, Akka, and then Lagom, the opinionated microservices framework built on top of Akka, and the Play framework too, also on top of Akka. And then there's also the Spring coming from the folks who actually produce the Spring, that's the VMware, what used to be Pivotal. So that's Project Reactor, which actually the set of operators are essentially the same as the RxJava 2 because it's the same group of engineers that work on their open source libraries. Okay, then another thing I'd like to bring to your attention is the RSocket that comes out, is kind of, I should say, it comes out of the consortium of 6 companies. So these are listed here. And it's currently kind of under the jurisdiction, I guess, underneath the Reactive Foundation, which in turn is actually underneath the Linux Foundation. It's very efficient. It's an application level protocol, layer 5 and 6, based on reactive streams, and also very flexible. All of these things I'm listed here, reactive back pressure, flow control, all of these things too. So. And yeah, I won't have time to go into all the details, but we can talk about it some more too later. Okay, so quick thing then, before I go into a bit of a Vertex, is the small rye mutiny too. Just want to point out to you that where, mutiny is serving as at too. Maybe I should have shown this earlier. So you can see in the reactive world, there's the manifesto, the system, the extension, all of these things. Then over here, there's the programming aspect, the streams and back pressure, data flow, and that's where mutiny kind of focusing the library serves in this area. So for this too, I borrowed this this diagram from the mutiny documentation. So you can look that up if you like. So okay, so now then let me quickly. I realize, well, it's kind of like so much stuff to talk about, so I have to go a little bit faster. I hope to also show the deployment part, which is what I'm trying to show. So Vertex, okay. Quickly. So these are like some of the use cases we can use for, make use of Vertex for. And essentially, Vertex as the core library. So first and foremost, just want to point out their event bus. And it's a bit kind of like, make your development of reactive simpler too in that sense. So you can see. So I won't kind of read over all of it here, but essentially writing the TCP clients and servers, writing HTTP clients and the event bus, and deploying and then deploying verticals. All of these things handled by the Vertex core. And these are like example of using your POM file, how you can specify your dependency. Currently they're at the version 3.9.2, but 4.0 is supposed to come up pretty soon too. So it supports from Gradle too. And in order to do your Vertex, is basically you just need to spin up your control center. So in order to have your control center, it's relatively also straightforward. All you need to do is vertex.vertex, and it will bring up your control center. And then if you want to add in any runtime options to it, you can kind of specify programmatically, like in your control center, you can basically also pass in your Vertex options. In this case, is an example of setting your worker pool size to 40, but you can set like clustering, set other kind of parameters too. And as such, Vertex is very event-driven. So these are some of the example events, like timer has fired, some data has arrived on the socket, or data has been read from disk, an exception has occurred, or HTTP server has received a request. And some event handling examples. So this one is probably one of the simplest case. You can use Vertex to set a timer. So just call set periodic, specify how long you to wait the event frequency. So here I have like 1,000 milliseconds, which means it's like a second. Then I print out a timer fired to the console. And then there's also receiving an HTTP request over here. Now for Vertex, you always want to use a handler to handle to any kind of events. So in this case, for HTTP, I have a request handler and to print out hello world. So in Vertex too, it has a concept of the vertical model. It's similar to the actor model, like Akka, which kind of is a derivative, derived from Erlang, right? So, but Vertex Verticle is not exactly the same like that. It's not a requirement, but it's a unit of deployment for the runtime too. And the vertical processes incoming events over the event loop. And so example of events like receiving network buffers, timing events, all of these things. And some example or some more discussion about event loop. They are generally used in asynchronous programming models, and each event gets processed in a reasonable amount of time. So then the idea is not to hold up, not to block the event loop. Every event loop is attached to a thread, and by default, Vertex attaches 2 event loops per CPU core thread. And event loop and vertical. So a regular vertical always processes events on the same thread. And so no need to do any kind of explicit, if you're using it to do any thread coordination. And it can be passed some configuration, and it can also be deployed multiple times too. And this is like a diagram that explains, like, if you're doing a configuration, you just pass to the vertical, and then it gets deployed. And basically, too, is that then the event bus will then handle this accordingly. And you can be listening for some changes in your configuration too, and that type of stuff. So it can, basically any kind of configuration changes can be hotly deployed back into your server like that. So you can also deploy a vertical many times, multiple times. So, okay. And here, some polyglot kind of discussion too. Like I said, I talked about it earlier. It supports a variety of languages. I think for Python enclosure will be in earlier version. It may not be supported yet in the later versions. And it doesn't force any usage of any languages, but it allows programmers to pick and choose any or all. Really true interoperability made possible essentially by the event bus and the messaging infrastructure. So this is an example too that I will be showing. Like, let me kind of show some code. It's been kind of I just keep talking. So okay, so example illustration here. I just do an example of an API gateway. So sort of kind of handles funnels some HTTP requests. It runs in the JVM, and then I'm basically implementing my worker vertical. In Java and Kotlin and JavaScript. So for the JavaScript part, I'm using a sock.js bridge to kind of connect the two. But otherwise too, it's any language's implementation of a vertical are handled by the event bus. So let me then exit in this case and bring up my code over here. And and multiple things. So okay, I think this is the one. Yeah, I just have okay. Just very quickly too, because assuming not everybody has done it, so I will just quickly show the code. And this is what I will be also using. Hopefully, if I have time, can quickly show you how do you deploy it to the cloud. So over here too, to do a vertical, all you need to do is just extend abstract vertical in here. So kind of explain to you here. Well, actually, I think because I was changing my build Gradle, so I think something is broken in here. So, well, anyway, sorry, but otherwise too, it should be like showing up. I was hoping to show, right, the Java doc to it, but it will work anyway. I just don't pay attention to the problems right here. So it's always when you're trying to do code stuff, it always have something. So over here too, the hello world, all I'm doing is just in my start. So any vertical, you just need to override the start method. And then over here immediately, I can just do like a Vertex set periodic to set a timer, or also like create an HTTP server listener in here. So over here, in the, this is kind of include a couple things with a Lambda. I'm also logging some information to the logger, and also then print out my hello. And then I bind, the port to my listener in here. And so in order to start your Vertex, all you need to do in the main, you just do vertex.vertex, and then you do a vertex.deploy vertical. That's how you do it. And it's just as simple as that. Okay, so that's that. And then let me then move on to my API vertical here. Actually, it's kind of strange. I actually had it working earlier. I'm not sure like why. All of a sudden, something maybe I kind of right before I start, I realized I changed something in my build file. So, okay, let me then take a really quick look because I realize time is running short. So that with the polyglot example, likewise too, right? With my vertical, my main vertical, I'm extending abstract vertical. And then in my start here, as you can see, this actually I'm making use of the configuration, essentially the config retriever that I'm using in here. So then this way I can set up my configuration, and all I'm doing is that I create my config retriever, and then I pass in my Vertx and then my config retriever options to add the file store to it. And then over here too, once it's up in that case, then over here too, I'm also like calling a method to do all the, essentially starting it up and also initiating and deploying all of my worker verticals in there. But then also I want to point out is that the config retriever, I can set the listener in here and listen for any changes. So if any changes is changed in my JSON, my properties file, just a JSON, a simple one, that specify the port number and a couple of parameters in here, delay and some work account. Then basically, any changes to that, then they will get picked up and essentially being processed right away, hotly deployed. So, okay, so let me kind of go then without kind of getting in all of these things, but in my startup, I'm also like specifying my router and all of these things, and like over here with the sock.js bridge for setting it up to talk to the JavaScript. Okay, so all of those things are in there, and as an example. Then I also like start my HTTP server in here. So over here, if all succeeded, then I basically will call the method to deploy all of my worker verticals in here. So let's take a quick look then in the in my deploy all of these verticals. So deploy Java worker. So same thing when I do my deploy my Java vertical. All I need to do, I take the control center over here and do a .deploy vertical and pass in my class name of my vertical, and then the other options, and then also then with the the response that needs to happen. And I'm also logging some of these kind of metrics too. So just so you know. So again, this is just a demo program, so nothing too fancy other than just showing the mechanics of how we kind of can support like polyglot case. So over here too, this would be my deploy Kotlin worker. And it's pretty much kind of same kind of code, and I can refactor it. But for now, for demo purpose, I just also do a deploy vertical and then give it the Kotlin worker vertical class name, or class.get name to it. And JavaScript, likewise. I also do deploy vertical and then pass in my JavaScript file to it. So that's pretty much it. And of course, there are some more details too, but I won't, it doesn't appear I have too much time to show. But in the meantime, let me swap. Neil, can I talk 2 more minutes maybe? Kind of make sure. I kind of realize it's already 6
Yeah, sure. Go ahead.
Yeah, okay, thank you. I try to be a little bit kind of, okay. Let me, okay, the only thing is I can't get to my, okay, here we go. All right, so just showing the part to the cloud now. Okay, so I'll bring in my IBM Cloud Console. So the idea is that, okay, let's say, right, I'll just talk through it. So this is my OpenShift console that's kind of deployed into my IBM Cloud. Of course, there are a lot of magic already, so I won't have time to discuss all of it. But it's pretty much kind of standard thing. I open up my OpenShift console, and I also want to make sure that I have installed a serverless operator. So the serverless operator for OpenShift is essentially the Knative. So in this particular case, I'm actually using Knative serving to do the deployment. And then also there's Knative eventing, but I'm not leveraging on that just yet. Yeah, maybe at the next, some other future presentation, I'll do that as well. So, okay, so over here, these are just, when you're on the console, you can kind of capture how you can actually log on. And the nice thing about this is that there's a Cloud Shell. So Cloud Shell is what you can invoke when you go back. Let me kind of go back to this here. So on your console, there's also a option for you to open up a Cloud Shell. So that's kind of really convenient having a Cloud Shell. So over here, I happen to be having my code ready. So over there, okay, now I'm doing some magic in here. I basically build my code, and I then would do a Docker build image. Essentially build the image, and then with the build image, then I push the image to my Docker Hub. Then all I'm needing to do, in this case, then look at, all I will need is a service YAML file to describe. So this is my service YAML file, that is Knative kind of, as you can see. So the nice thing about Knative is that a very quick note is, it handles the traffic for you, handles the version for you, and the revision, and also and is using, like by default, is using Istio underneath. But you can also use other kind of surface mesh like networking kind of libraries underneath that is on with OpenShift that can support this or Knative. So okay, so all you would need to do a very simple case of hello world, then I can just do this over here. And I quickly want to show too is that there's a spec section in which I specify the name of my application. I also want to give like a version, like a V1, for example. So that's how then it's able to tell that you're, it helps you with some versioning that's there. So yeah, all of these details, I won't go into all the details description, just want to show to you. So my image is here. Now over here, it just happens, this is a conference I just recently did. So because I know that works. So I'm just trying to show it in here. And this is how we can pass in all of the environment information through this environment variable called target. And that's how I can do it. So now, assuming there's a lot of magic to do. So all I need to do, OpenShift client OC, and I just need to do an apply, or actually, yeah, apply and dash file name. And I should be able to then do service. It should be able to do the deploy. Oops. Okay. I think it always happened, right? This kind of thing. Why is it not? Oh, I think I know why. But you get the idea. I think I should be using like a double dash. So sorry. I think I'm kind of already very much over time, but yeah. So that's the idea. So it's, of course, barring all those setup too. Yeah, anyway, so I actually seem to be having some issue in here, but I know it works because I've done it before. But again, that's the idea. I think there might be some setup in my particular situation too. So, but again, just wanted to quickly show you the deployment part. It can be like as simple as that, right? After you set up everything. So that's the idea. And then let me then get back to my slide to kind of finish this up and just a couple more slides too, hopefully not too long. But I cannot get to my, I'm so sorry. My mouse, I kind of couldn't get to it. Okay, I'm sorry. Okay, maybe I'll use my touch bar. Okay, here we go. So, okay, so I just did all of that. And now I just want to, okay, build part I also did, but what is going on? Oh, I think I swapped the other thing. I'm so sorry. Okay, well, I'm so sorry. Let me swap it back. I'm sorry. Okay, here we go. Okay. Okay, so these are just example of if you want to do Docker build and Docker push and then do the OC apply file name, and that's what is needed. So, okay, so with that comes to an end, and I appreciate your patience with me. So as mentioned too, I'm also doing a live stream on Twitch every Wednesday. GMT, actually, I should say Chicago time, it should be GMT -6. And it's Wednesday about 12:30 to 1. That's the time I'll do for about an hour to about an hour and a half. So currently I'm working on some reactive extension, RX operators. And also too, if you like to continue conversations, I also have a Discord channel. So if you want to join me on Discord, you're very welcome to. And these are some of the resources, links. So if you want to get more information on the reactive systems, on the IBM developer, you can look that up, and the Knative documentation as well as OpenShift information. So, and with that, this comes to an end. Thank you so much. Appreciate all your patience, and thank you to Oli, to Alexi, to the Scale by the Bay. It's been a fantastic event. I enjoyed it a lot. Thank you, Swapnil, for graciously being my host and not rushing me. So thank you so much. And everybody, please have a great weekend. Stay safe and healthy.